This project is called Crime Rates in Los Angeles, and the authors are Weihao Zhou, Kaiwen Yang, Xu Han, and Laura McCallion. The dataset we used is arrest data from LA Open Data. It includes information on crimes such as the category of crime, the time and date, and the location of the crime. The data source updates weekly. In this project, we've aimed to analyze crime data in order to investigate trends regarding the quantity and type of crime and its relationship with the time and location of the incidents. This includes several types of exploratory visualizations as well as a time series analysis. This project uses two types of interactive visualizations in order to explore trends in the crime data. The first type of visualization is a stacked trend graph, where the 5 shades in the plot correspond to the top 5 most common categories of crime. This visualization is interactive. The date selector below the plot allows the user to select months within a 2-year period and is therefore capable of showing changes in crime trends through time. The second visualization shows the location of crimes on an interactive map of the LA area. This is possible as the arrest data includes an approximate longitude and latitude for each incident. This visualization is also interactive and includes 2 methods of interaction. The first is a date selector similar to the stacked trend visualization that allows the user to examine trends in crime rates over time by adjusting the range of dates. The second allows the user to switch between visualizing violent and non-violent crimes, which allows the user to compare the densities of these 2 categories of crime.
Hey guys, this is Kaiwen Yang, and I'm going to explain how this crime map works and what information we can get from it. So this scatter map shows us the distribution of different crimes in different regions in Los Angeles. The different color of the marker means different area. If we put our pointer onto the marker, we can see the detail of the area code. And there's 21 different areas specified in this data set. We can see the detail of it on the right hand side. So users are able to see this information by specifying a time range and crime type in the box given below. The size of the map can be adjusted like that, zoom in and zoom out to see the different detail of the location information and the distribution. If users want to know the exact location of certain crimes, they can just zoom in and put the pointer onto a particular marker to see the exact location information of that crime. And if the user just want to know the overall distribution, they can just zoom out, so like that, and we are able to see the overall distribution. If more crimes happen in a certain area, then the shades are darker. For example, we can see the shades are darker here than shade here. Okay, so now I'm going to show you how to turn the 2 parameters to visualize such information. So first we need to click on the time frame. We need to choose a starting time first. Let's go with November 1st. And then we need to choose ending time. Let's go with December 1st. Okay, so we need to wait for a few seconds for the map to update. Yep. So now it shows the information about the non-violent crimes from November 1st to December 1st. If we want to know the violent crimes, the distribution of violent crimes, we can just change the crime type in here. We can by clicking it and wait for it to update. Okay, so now we can see the distribution of crimes from November 1st to December 1st. As we can see, the number of violent crimes are far less than the number of non-violent crimes, just by looking at the number of points on the map. And the shade in around this area are much darker than shade on the other area, so we can expect the number of crimes happen in this area are larger than crimes from the other area. So yep, this is how you can get the information you want from this crime map. So now I'm going to show you the first graph on this website and how to use it to get the information you want. This is a line plot, and it contains of 5 different layers. Each of the layers represents one of the top 5 most frequently happened crimes in Los Angeles. As we can see here, the y-axis represents the total number of crime in a given month, and x-axis shows different month. With this line plot, we are able to visualize the changes of the total number of crimes from month to month. And to get the information you want, you could just specify a time range in the time frame given below, and the return result will include the starting month and the ending month you choose over here. So I will show you how to manipulate this line plot to get the result you want. So you can just simply click the time frame here, and then you need to choose a starting month first. So let's choose June 1st, and then the line plot should update it to show you the relationship between June 1st to October 1st. So let's choose another ending month. Let's go with December 1st. So because there's still days remaining in December, so we can see there's a decline, a sharp decline in December. But the other months are showing a kind of a constant number of crimes. So this is just how you can manipulate the time frame to get the result you want.
We used the API provided by Los Angeles Police Department to pull down data from the public data source. Since we've decided to analyze 2 years of data, and there are around 200,000 rows in it, we decided to do this using 3 Python script files that work together. So the first file is called database.py. Basically, this file provides 2 functions that we will use later. The first function is called assert crime, and the second function is this function allows us to cache the result in memory. We will call load data.py first. This function will bulk process all the history data and use insert many to insert all the history records into our database. And after that, data_acquire.py will be run. This will check whether there are any updates in the public data source every 15 seconds. Fetch all crime as data frame will be run as well, making sure that the result is cached. And concurrently, app.py will be run, making sure that the website has the latest updates.
Hi guys, this is Wei Hao. I'm going to talk about the model comparisons in our data enhancement part, as well as the reference and next steps. So the first part of data enhancement, I just pull out all the data that we stored earlier in the MongoDB for the initial data loadings, and then convert it to the pandas data frames here. It has over 190,000 rows. It contains all the information of LA crimes from January 1st, 2018 until now. The second step, we try to build up a time series model to predict the number of crimes that happen in LA City. I'll just quickly go through this exploration phase because I'm trying to determine how should I design a model and tune the parameters. I just create a new data frames that summarize the daily number of crimes in LACD from January 1st, 2018 to now. And I make a time series plot. We can see clearly this is not stationary. And that's why I applied first differencing to the crime numbers. It looked pretty reasonable to me right now. And it looks pretty stationary. I use Dickey-Fuller test, which I think the new hypothesis is the time series data is not stationary. So what we want to see is we can actually reject the new hypothesis. And we can see the p-value is pretty small here, which is great. It suggests that stationary is achieved. So I just will set the little d, which is ordinary differencing in time series model, to 1 in the fitting process. And here's two methods of fitting the model. It's pretty similar to SARIMA in R, which automatically tune the parameters for you. There's no obvious better choice, so I just pick whatever is quicker. The random method I think is quicker than the stepwise method, so I will just use this method in my model later. And for the model part, the baseline model of our data is just going to predict the sample average. Here, the function which allow two input is area and the whole LA. The area is from 1 to 21. That divide whole LACD into 21 area. Or there's second options. You can just to predict the whole city, the number of crimes for whole cities. And here's the prediction result, which is just simply the past data's mean. And we can see that from 1 to 21, it's pretty interesting that 7 and 8 has pretty low number of crimes. And whole LA we have on average 274 number of crimes each day. And for the time series model, I did similar things, which create a new table that summarize daily crimes numbers. And then I fit a ARIMA model, and I use the best model fitted and then to predict the next 30 periods. Notice that I just cut off 30 days here as a test data. Similarly, I did here too for the baseline model. I just cut out the last 30 days as test set and use the remaining data to train the model. And then we prepare a plotly figure here to visualize the model predictions. And the function return these figures and also the predictions of the best models. And then in order to better compare two models, I wrap up the comparisons into a little function, which in the function that calculate the mean square errors for the baseline model, and calculate the mean square error for the time series model, and then put a result into a table. So for the comparisons, model comparisons, I just did an example here, which is going to compare the predictions for the whole LACD. Here's the visualization of the prediction. We can see it's not that good because the prediction doesn't capture the descending trend here. Here is the numerical predictions of next 30 periods, which is the red line here, the predictions, and also a summarized table for the time series model and the baseline model. We can see, although it's not that good, but it's still better than the baseline model because the mean square error is lower. So we can conclude that our model is better than the baseline model, which just simply return the past average. So also here, I'm going to talk about the reference and the next steps. We can click about page here in our website. So basically, the next steps, we just try to fix the initial data loading issues, which is quite slow in our website. But I think it's pretty reasonable to me. But anyway, next steps, we also want to add a new additional interactive dashboard for the crime number predictions, which I show here in the data enhancement part that allow users to choose the area or whole city for the prediction to predict the number of crimes that will happen in futures in area city or by areas. For the reference, here's the GitHub report link. Here's the data set. Also some helpful visualization reference Plotly package here, and also some previous work we have looked into, but we didn't try the similar things. Those are Kaigo's post. Here's the links, and I think that's it.